Okay, so in this video, what I want to do is to do some practical examples that use everything that we've talked about thus far. So arc length and radians and the radius of the circle and sine and cosine and all that kind of stuff. And so, so let's get started with this problem right here. Module 7, Investigation 10, problem number 7. Says a skier skied in a circular trail, starting at the position 2.50 on the circle and ending at the position negative 2.3775, 0.7725. This is to start by drawing a picture of the situation. Let's do that. So let's, I wonder if this will work. Let's go ink to shape, just see what happens. Why not, right? No? Okay. Maybe. No? All right, well, let's just do it the other way. All right, there's a pretty decent circle. Okay, when I crossed it wrong, but anyway. So we start at this position here, which is 2.50, and these values are measured in, I'm not really sure what value these are measured in. Anyway, so we're at 2.5, 0, and then we end at negative 2.3775, positive 0.775. So that's about here. It's not beautiful, but it's okay to work. Negative 2.3775, comma 0.7725. Now, what they ask us to do in part B is to find how many kilometers. So I guess this must be in kilometers, although way to go, author of the book, for making that super plain. Anyway, how many kilometers did the skier ski? So that value, if I'm looking for that value, that's this value I'm looking for, right? This is because he's skiing in a circular trail, and this is how far he skied, is from over here, right? So what I'm really looking for here is I'm looking for S. And we know that to find S, that's the angle times the radius. Well, the radius is easy, that's 2.5, but we don't know the angle of rotation from here over to here, right? What we need to find is this angle. So what we're given is we're given some coordinates at the point, right, on the terminal ray, and we're given the radius, the 2.5. We need to find the angle so that we can find the arc length. All right. So what we're going to need to do is to use this point that they've given us and recognize the fact that this point is our cosine theta, our sine theta. Now, in the textbook, it asks you to use both sine and cosine, the inverse sine and the inverse cosine, to solve this problem. I'm just going to recommend that you use one or the other. If I was looking at this and I was trying to decide, should I use inverse cosine or should I use inverse sine? Because I can either set up this equation, 2.5 times the cosine of theta is equal to negative 2.3775, or I can set up the equation 2.5 times the sine of theta is equal to 0.7725, right? Those are the two options that I have. Well, if I'm wanting to end up with an angle in the second quadrant over here, I know that inverse sine is not going to get me there. Inverse sine is going to deliver a quadrant 1 angle, and then I'm going to figure out the quadrant 2 angle, which I can do. That's doable. But if I use inverse cosine, I know that that will actually deliver an angle in the second quadrant because the range of the inverse cosine function is from 0 to pi, right? You may remember that from before. Let's go right here, right? So the inverse sine function has this range here, right? Just from negative pi over 2 to pi over 2. So that's the fourth quadrant and the first quadrant. And then inverse cosine has a range from 0 to pi, which means that's the first and second quadrants there. So if I'm wanting an angle in the second quadrant, this one will probably be the most direct route. I don't have to use it, but it probably is the most efficient method. So let's take a look at this. So if I divide both sides by 2.5, so I've got cosine of theta is equal to negative 2.3775. Those look like twos. Let's fix that. Goodness. 775 divided by 2.5. Then I can say the inverse cosine of negative 2.3775 over 2.5 should be the angle that I want. So let's do that calculation. Let's see what comes up here. I don't have the convenient information on my screen here, so I'm going to use my graphing calculator in my hand. So we're going to go second inverse cosine of 1.874. Nope, what am I looking at? I'm looking at the wrong problem. Pardon me. Inverse cosine of negative 2.3775 divided by 2.5. Okay, so that gave me theta is 2.8273. Okay, now that's part of the way there. Now what we said we wanted the angle for was so that we could figure out the arc length. So this means, so then the arc length is going to be 2.8273 times the radius, 2.5. Let's take this value and multiply by 2.5, and that will give us 7.0681 kilometers. And that's how far the skier skied. Okay, so the question under this, number 8, goes along the same lines. I'm going to give you some time to think about that on your own. I may post another video that gives us that information. So I'm done, and thanks for watching.